Texan Global School. Parabola equation. In this class, different forms of the parabola equation are analyzed. By definition, a parabola is the locus of a point in the plane such that its distance from a fixed line, called directrix, is always equal to its distance from a fixed point, called focus, of the plane that does not belong to the line. The case where the focus is on the directrix is excluded. We can see on the board that the focus is denoted by the letter F. L is the fixed line called the directrix of the parabola. F, lowercase, is the axis of the parabola, which is a line perpendicular to the directrix. E, capital letter, is the point of intersection of the axis of the parabola and the directrix. V is the vertex of the parabola, which is the midpoint of segment A, F. B' is a chord defined as the line segment that joins any 2 points of the parabola. C' is the focal chord, which is a chord that passes through the focus. L' is the latus rectum of the parabola, defined as the focal chord perpendicular to the axis. Finally, P is the focal radius, which is the line that joins the focus and any point of the parabola. Now, to define the first standard equation of a parabola, consider a parabola with vertex at the origin and axis coinciding with the x-axis. If the focus is point F with coordinates p, 0 on the x-axis, then its directrix L is x equal to negative p, since, by definition, the distance from the vertex to the focus is the same as the distance from the vertex to the directrix. Defining p, with coordinates x, y, as any point on the parabola, draw the segment p, a, perpendicular to L. By definition of a parabola, by taking any point, the distance to the directrix is always equal to the distance to the focus. Algebraically this is, p equals p, a. If we obtain the distances of the line segments, for the segment f, p, substitute the points obtaining the square root of x minus p, squared plus y squared. For the segment p, a, by substituting the points results a distance of x plus p. By substituting into the algebraic definition of a parabola, equalize those expressions. When developing, square both members to eliminate the square root. Develop using special products and simplify obtaining y squared is equal to 4 times p, x. This is the simplest form of the equation of a parabola called the first standard equation. In summary, the equation of a parabola with vertex at the origin and axis on the x-axis is y squared equal to 4 times p, x. Where the focus is the point F with coordinates p, 0 and the equation of its directrix is x equal to negative p. If p is greater than 0, the parabola opens to the right, and if it is less than 0, the parabola opens to the left. Analogously, the equation of a parabola with vertex at the origin and axis on the y-axis is x squared equal to 4 times p, y. Where the focus is the point F with coordinates 0, p, and the equation of its directrix is y equal to negative p. If p is greater than 0, the parabola opens upwards, and if it is less than 0, the parabola opens downwards. In both cases, the length of the latus rectum is the numerical coefficient of the first degree term or 4 times p. Let's look at an example. A parabola whose vertex is at the origin and whose axis coincides with the x-axis, passes through the point p with coordinates 1, 2. Find the equation of the parabola, the coordinates of its focus, the equation of its directrix, and the length of its latus rectum. Since the parabola has a vertex at the origin and its axis is on the x-axis, use the formula, y squared equal to 4 times p, x. Directly substitute the values of the given point into the equation, to obtain a value of p equal to 1. Now, substitute the value of p to obtain the first standard equation of the parabola, which is y squared equal to 4x. Using the deduced theory, we can obtain the focus, since it is point F of coordinates p, 0. So, the focus is on point 1, 0. Since the distance from the vertex, in this case the origin, is the same towards the focus and towards the directrix, the equation of its directrix is x equal to negative 1. Since p is greater than 0, the parabola must open to the right. We will graph this analysis. Isolate y as plus minus the square root of 4x, so that we can tabulate. If we discuss the equation, we can see that the domain includes all values greater than or equal to 0. Any negative number will generate an imaginary number, so there is no locus on the left side. Tabulating then, propose values greater than or equal to 0, thus, results the coordinates and the behavior of the graph. Parabola with vertex at the origin and axis on the x-axis. On the other hand, if the coordinate axes are moved to a new origin of coordinates h, k, the new parallel coordinate axes will be x' and y', thus generating new coordinates. Then, the transformation equations from the old system to the new coordinate system are x equals x' plus h and y equals y' plus k. If we now consider a parabola with vertex at the origin and axis coinciding with the x-axis, we can perform the translation of coordinate axes. The coordinate axes can be moved parallel to a new origin h, k. The new parallel coordinate axes will be x' and y', generating new coordinates. Then, the equation of the parabola referred to the new coordinate system is y' squared equal to 4 times p, x'. Performing the translation of coordinate axes, isolate x' and y'. Now, substitute in the previous equation obtaining y minus k squared is equal to 4p times x minus h. Analogously, x minus h squared is equal to 4p times y minus k. This is the second standard equation of a parabola, when its vertex is at point h, k, and its axis is parallel to one of the coordinate axes. In summary, the equation of a parabola with vertex at h, k, and axis parallel to the x-axis is y minus k squared is equal to 4p times x minus h. If p is greater than 0, the parabola opens to the right, and if it is less than 0, the parabola opens to the left. The focus is the point h plus p, k, and the equation of its directrix is x equal to h minus p. The equation of a parabola with vertex at h, k, and axis parallel to the y-axis is x minus h squared is equal to 4p times y minus k. If p is greater than 0, the parabola opens upwards, and if it is less than 0, the parabola opens downwards. The focus is the point h, k plus p, and the equation of its directrix is y equal to k minus p. Let us remember that p is the length of the axis segment between the focus and the vertex. And the length of the lattice rectum is the numerical coefficient of the first degree term, that is, 4p. Let's look at an example. Find the equation of a parabola whose vertex is the point 2, 1, and whose focus is the point 2, 3. Also find the equation of its directrix and the lattice rectum. Since the vertex and the focus of the parabola are on the same axis, and the vertex is below the focus, we can deduce that the parabola opens upwards. So, use the formula x minus h squared equals 4p times y minus k. Directly substitute the value of the given vertex h, k into the equation. Now, we can calculate the value of p considering that p is the length of the axis segment between the vertex and the focus. Subtracting the ordinates between the given points, we obtain a value of p equal to 2. We confirm that the parabola opens upward since the value of p is greater than 0. Now, substitute p to obtain the equation of the parabola as x minus 2 squared equals 8 times y minus 1. From the equation we can see that the length of the lattice rectum is the numerical coefficient of the first degree term. This is equal to 8. Since the distance between the vertex and the focus is p equal to 2, that should be the same distance from the focus to the directrix. So, the directrix equation is y equals -1. It could also be calculated with the formula y equals k minus p. We can verify that since the focus is the point h, k plus p, it is effectively the given point 2, 3. In this way, we can see the behavior of the parabola. Now, the general form of a quadratic equation in the variables x and y, lacking the term xy, is shown on the board. Two cases are derived from it, which represent a parabola. If you want to obtain the standard form from the general form, complete the square. If you want to obtain the general form from the standard form, develop it algebraically. Let's look at an example. Show that the equation x squared minus 4x minus 8y plus 12 equals 0 represents a parabola. Find the coordinates of the focus, vertex, lattice rectum, and directrix. So, we have to complete the square to obtain the standard equation. Then, send the independent term to the right side of the equation. Group and multiply the numerical coefficient of the linear term by 1/2 and square the result. Now, add the obtained value of 4 to both sides of the equation. In this way, results a perfect square trinomial. It is factored as a square of a binomial. Hence, the left side of the equation is developed obtaining the standard form, x minus 2 squared equal to 8 times y minus 1. From it, we can graph and obtain all the elements of the parabola. The vertex is at point h, k, that is, in 2, 1. From the same equation, we can directly obtain the value of p, in this case, it is equal to 2. Since it is greater than 0, the parabola opens upwards. The focus can be obtained with the coordinate h, k plus p, so, the focus is at point 2, 3. The latus rectum measures 8, since it is 4 times p. And the equation of the directrix is y equal to k minus p, so it is y equals to -1. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com